In the first half of the lesson, we finished discussion of the example, call it pet data. So we finished at part 3. We started at the previous lesson, and we finished completely, hopefully, at this lesson. And for the second half of this lesson, I want you to open, if you didn't, if you already cloned it, example from Google. I linked this to MarsPhotos, MarsPhotos Android on Slate week 5. I cloned this at the previous lesson, so I assume that some of you cloned it. I have it already on my hard drive, so I open it from hard drive. If you didn't clone it, please clone it. So for the second half of the lesson, I will quickly discuss what is inside, and we will practice with this example by changing code. This example is using dependency injection that Google calls manual dependency injection, and there is no exact standard, as I understand, but they came up with some idea, relatively recent, and started to call it manual dependency injection, and previously it was manual dependency injection, it is whatever works, essentially. So by looking through examples from Google in this course, from Google, not our course, but from Google, I found two variants of this dependency injection. It is one of them. It's one of the two. So please open MarsPhotos Android and do not close pet data. Just stop it from running. Do not close it because I want you to copy-paste libraries from it. Rather than browsing Google website, developerandroid.com website for libraries, it's easier to copy-paste libraries from pet data because I already copy-pasted those libraries. Okay, so just stop running it and open project MarsPhotos or clone it. I will open it from hard drive. MarsPhotos Android open, new window, because I want to copy paste stuff. This is not nice. Hopefully it will not cause issues. I'll say see details and report and clear. Okay. So let's run this project to have idea what it is doing. After this, or remind idea of what it's doing, and after this we will look at the code. So I run it. It connects online to a server and gets data. But you see I didn't switch screen preview, right? This is not actual program. This is preview of the screen. So it shows loading data preview. So in order to run it correctly, I need to stop it, click on app. So this will run entire app. Because I made mistake, I was running preview. And run. So you see quick loading. Now it's connected to website, downloaded data. Data contained link to images, and it was using COIL library to get images from web. The same as in our example, pet data. Pet data is using COIL library to get images from web. Okay. So inside of pet screen, you see that there is a list body. In the list body, we can find a sync image. This function belongs to COIL library, and image folder, this is web folder that contains those images, and this is file name. Okay. So it is picking data from a web Image folder is, I define it as here. See, this is image folder. It is web address for the local server. A similar idea is here for MarsPhotos. It grabs JSON from web, and JSON contains name of the files online, and it is using COIL library to display the stuff from web. So let's browse through the code to get some bigger picture of what is going on. So if we open libraries, we will find that in global project we don't have a reference to Hilt library, right? Hilt modules. Because it's not using Hilt, it is using manual dependency injection. In Gradle, in APP module, we will see that it is using retrofit, but not with Moshi, but with Kotlin X. If we compare API calls inside of the code, it is quite close. It's not identical, but quite close. So so this one, retrofit also included. This is for testing, so they have separate testing for it. A view model compose is included. They didn't create it as a second line, like separate line, but this is also copy-pasted to empty project. Okay. So what is on the top? They didn't change it to 17, but I changed it to 17 because I figured out when I include Hilt libraries, it doesn't compile. So I had to change it because of Hilt. They keep it 34, the same as I do. This is to suppress warnings about unstable API usage. Remember that we need to add some annotations on top of functions just to make code compile that we know that it is unstable API, like experimental API. So they did it globally, so they didn't have to include this on top of the functions. Right. And they also included this one. Because it is not here by default, because they use serialization library from Kotlin. So this part, Kotlin X is using serialization library from Kotlin. So for this reason, they have plugin for Kotlin serialization. My code doesn't have this part because it's not using it. If we browse for data structure, they also have a data folder, the same as my code. In the data folder, they have APP container and definition of repositories. They don't have a separate package for repositories, perhaps to have it simpler, shorter. And speaking about packages, this structure of packages is not cast in stone. There are variations, just apply common sense. I tried to stay close to code from the textbooks that we use and code from the example. So my code is somewhat in between. So again, package names, they're not cast in stone. They just trying to apply common sense to separate code based on separation of concerns. They also created folder for network. In my case, API is in data folder. And I created remote for that, and this goes to remote. Technically, it's remote data. Definition of the class, in my case, it is in domain. In their case, it's a model. Model is another kind of word for the same thing. The idea comes from model view controller. It's an older concept, but still in use, where controller, it is the means of displaying stuff, so it is logic for displaying. A view, it is actual code for displaying, like XML layouts or compose function. And controller, it is code in between. So in a code in between of data and what is displayed. When we started to use compose functions, we have bad separation between, no, bad. It's good, but I have less separation between controller and view, because compose, it's kind of in between. So Google no longer uses this concept of model view controller, but model can survive it from that older ages. So since there is no separation, they call it just UI layer, user interface layer, that control view and controller together. And model, it is just classes that you want to display inside of the view. They don't have UI state, or they do? Yes, they do have UI state, but it is defined in UI, in screens, so they have view model, and UI state is defined inside of view model class. See? Okay. I prefer it to separate classes to different files, so it is obviously from the code what we have inside. In this case, they do have UI state, but it is part of the file of view model. All right. As in my code, they have something that corresponds to loaded data, but they call it success. Success is loaded, kind of synonymous. Arrow and loading, right? And success contains list of objects that match data coming from internet. In their case, they don't have two different kinds of objects that is mapped to the data from internet and object used to display data. They use the same class. And it is not a great idea, but they use it probably to make code shorter, so they don't have two classes. If we look up textbooks on software design, they recommend separation. So this is reused in MarsPhotos is reused to display data and to receive data. Since they use different libraries to process data, they have different annotation. In my case, I don't have annotation at all, because by default, it works fine, unless you have a name in the code that cannot be a variable. Inside of JSON code, that cannot be a variable. For example, contains minus or underscore. This you will have to include some annotation on top in Motion library. It will be different annotation, not this one. You need to look up documentation. In this case, they demonstrate that if data not in the format that you want to use as a variable name, you can use annotation in the file. You can do the same in Motion library, but annotation is different. All right. So idea is quite close to what we have, but the arrangement of code is somewhat different. Please notice they have two classes, MarsPhotos app and MarsPhotos application. Named very similar, but they serve completely different purpose. So MarsPhotos app and MarsPhotos application. See? For this reason, just because these classes are named very similar but serve completely different purpose, I decided to call class that serves this purpose app screen. So in my case, this is app screen, to avoid very close names. Okay. If we open activity, we will see that MarsPhotos app is in exactly the same place as my app screen function. So it is just different name of the function, but purpose is the same. Okay. I tried to avoid similar names for different purposes. So they call MarsPhotos app function, and this function, MarsPhotos app, contains contains scaffold. Scaffold joins top bar and body, right? So they have top bar? No, they don't have top bar. Or they do. Let's find out. Surface modifier. No, here it is. Scaffold, top bar. They have top bar, right? That is calling function defined in the code, the same as in my code, because they copy-pasted their idea. Right? MarsPhotos top bar somewhere. UI screens. And home screen function. In my case, this is called body function. But what you see is totally different at this level, right? I just call view model without parameters. In this case, they provide parameter, which is factory. This difference is essential, because I rely on Hilt to create the factory in the generated code. They created factory explicitly. What is the purpose of this factory? We previously learned that view model function without parameters or with these parameters is kind of magic function that will create object if it doesn't exist, view model object if it doesn't exist of this kind, or if it does exist, it will find it and assign it. So if you don't rely on some system to create this object, dependency injection system to create this object like Hilt, you need to tell this function how to create this explicitly. So factory object, it's an object with the proper method to create view model. So this is the meaning of factory object. This object contains a method called by the system to create view model. So the obvious difference with this code, they have a factory explicitly. And we have a pass it, and view model is passed to home screen. This is home screen. In my case, it's called view. It's called pet screen, something like that. It receives view model and functions call it from the screen inside of view model. Right? So in my app screen, I have view model, pass it here, and functions is inside of other call. Okay, so inside of pet list screen, I have reload function, pass it to arrow body. So it is slightly rearranged with extra step, but idea is quite similar. So they pass it view model and pass it functions that will be executed on retry in view model. Okay. No, they didn't pass view model. They pass UI state. This is why. They pass UI state. Okay. So they have extra, I have extra layer in between. Okay. So the home screen is my screen, call it pet list screen, right? Pet list screen. So it's a little different parameters, but idea is quite close, right? They have state function, state object, and they decided to pass it to home screen, right? Mars UR state. Inside of the home screen, you will find that they use grid, vertical grid, which is equivalent to lazy list. It is lazy grid, which is equivalent to lazy list, but 4 more columns than 1. Okay. So home screen contains lazy vertical grid in the specified column widths, and so it's more than 1 column. And items contains cards, similar to my example, but in this case, card contains only 1 image. So, as you see, the biggest difference is in the place how we connect pieces of the code. It is not in the idea how we display it, right? So Mars photo card, where it is this one, contains image. In my case, it contains image and other displays, right? So how do they connect pieces? As already mentioned, they use dependency injection, and in order to use dependency injection manually, they use application class the same way. But since they do it manually, there is a manual code in application class. In my case, we implement Hilt application, and Hilt library will extend this class to store stuff inside. In this case, they store stuff themselves. So they created variable container. Late init means it is initialized not from constructor, but from other function. Which function? This one. Okay. If you remove late init, it will not compile, because it must be initialized either from constructor or directly, which is technically also constructor. So they connect pieces of the program inside of default app container associated with application class. So let's end. This is object assigned to container inside of app container. So let's see how this magic works. Default app container is probably defined here in app container. So they defined app container class and they defined implementation. App container is something that contains photos repository. So their definition of container, something that contains repository. So they can pick repository object to inject it into view model. They created implementation of it as a class implementing app container. And they connect pieces inside of the class. So they define base URL. In my case, it is inside of view model. They define retrofit object. In my case, it is inside of module, retrofit module. Right? I have a function that is calling it. In this case, it is just part of constructor. They create retrofit object. They define interface right here, not in separate class. No. This is defined as separate view model. No, so separate interface. API service, separate interface. But in app container, they initialize retrofit service by lazy. What does lazy means? We didn't see this before. We can treat it as a magic, but we can actually understand it deeper than magic. As a magic that will execute this code when we access this variable. It will execute this code and assign it to the variable when we access this variable. This is understanding as magic. how to understand it as a deeper level. If we want to understand as using deeper level, by means delegation. In this case, it is delegation to getter. So we delegate getter of this variable to this object. Object created by calling lazy function. So this is function that receives lambda function as a parameter. So we delegate getter to the object created by calling lazy function. Created by calling lazy, it is a function that receives this lambda function as a parameter. So when we call a getter first time, this function, lazy, will execute lambda function to create this object, and it will call this object when we access getter. So it is not magic, this is what happens. We delegated getter of Hilt to the object created by lazy function. And this function will execute lambda function to create retrofit on the first call. After this, it will reuse given object. Next. Since it's an implementation of interface, we have override MarsPhotos repository. So this is property declared in interface. So we override property declared interface in the interface. This is type, and also initialize it from by delegation to another object, right? So we delegate getter to the object created by lazy function. The same, first time when we call getter, delegated getter, this function will execute constructor call of network MarsPhoto repository. In this constructor, expect retrofit service as a parameter. Retrofit service is implementation of Mars service API. You see, so they connected items sequentially without using dependency injection from Hilt. It works, but if we have a complicated code, it will be far more complicated. So this is the reason why Google explicitly recommends using Hilt for larger projects. So which part is missing? So we have some container with repository, right? But this repository is used inside of ViewModel. So we are missing injection of repository into ViewModel. So this magic is not explained yet. Right? So they created something global, like app container, that contains reference to repository. But we still don't have magic of creating ViewModel. So they implemented this magic inside of Mars ViewModel. In the Mars ViewModel, they have companion object. It means it's a global, not global. It's shared between all view models, so you can access it by calling ViewModel dot. And they created factory inside of companion object. Factory is a special object that has a method to create another object. So inside of initializer of this object, they use library function, like application key. It's coming from Android ViewModel factory companion application key. It's some library association for this. To access application class. So this will be application class as a type of application. But they already extended this to MarsPhotos application, so they can typecast it to MarsPhotos application. Okay. So this is their application class, already typecasted. And this application class contains a reference to repository. You see, application container repository. So in the initializer, they call constructor of viewModel, and they provide a repository as a parameter of the constructor. So this is how they created factory object. By analyzing other Google code, I realized that it is not always the same. In some examples, they place factory not inside of viewModel, but in the special file dedicated to factories. So it also happens in other Google code. So in my opinion, they don't have a strict standard for this. Where to put factories? In some example, it is different file dedicated to factories of viewModels. So this is explanation of their code structure. Okay. So let's create a branch, call it useIt_Hilt or using Hilt, and try to convert it to using Hilt. If we have time, hopefully we will. Right? So in order to avoid messing with their code directly, let's create branch, new branch, and call it using Hilt. Great. So let's start with, since we want to use Hilt, let's start with including libraries. I opened a global KTX file, Gradle KTX file. And this is my pet data. In Gradle, global one. Okay. So I need this part globally, right? Copy. Globally somewhere here, right? So I paste it here. I try to keep changes to the minimum because the more I change them, it will kind of cascade. So I don't want to mess with it more than necessary. Okay. And now I need to synchronize because I edited this file. So I click sync. Okay, we didn't break it so far. Next, open build Gradle KTX. It is app file, and see what we need. Because we know this project works, right? So at the top, we need this specific part for dependency injection. So I pick this, copy, in plugins, for KTX. I keep this one. Hopefully there is no conflict. And paste it here. Now I want to synchronize it again. Because when I insert libraries, it may be picky of understanding libraries. So I synchronize again. It says no library found, which is okay. We didn't copy-paste library yet. So scrolling. Here it is. This is where they insert libraries, right? They inserted retrofit, cool. And after retrofit, I will put Hilt libraries before testing. So scrolling. Please notice it is 17, but they have 1.8. We may need to change it, but we don't know yet. So let's keep hoping that we don't need to. So this is what we need for dependency injection right now. So I copy paste this part into here. See, it's a little bit messed up. It's kind of expected. I will try to synchronize it. It's a Cradle project sync failed. Okay. I will try to fix what it's messed it up. Now it says capped, not known. Okay. Let's try synchronize again. See? Sometimes it goes nuts, you have to guide it, but eventually it understands. Okay? Okay. So let's try to run it, and if it's crashing, we have issue, we need to fix 1.8 to 17, and hopefully this will not be crashing. So let's stop it. Run it. Build failed. It's not crashed, it's build failed. And you see 1.8, blah, blah, blah. And eventually, if we read it, you see 117. Okay, so this is the reason why I was changing 1.8 to 17. So 1.8 to 17, 17, 17. Okay. Sync. Try to build again. Cool, it didn't crash, it compiled, right? But there is one more piece I didn't copy paste, but it's still around. It is this one. This is also capped related. We inserted capped at the top. Now we put it here. It makes errors more meaningful. So I say copy and paste at the bottom. Paste. Again, going nuts. Try to looks fine, right? Okay, sometimes it happens. Nothing is perfect. So let's try to synchronize. Did synchronize. Let's run to compile it. It does compile, so it's fine. So it took our libraries with some issues, but we fixed these issues. So let's do commit and call this commit in edit Hilt libraries. Edit the Hilt libraries. Right. Commit. To warning commit anyway. All right, next, resource project. Now we will break code because we have to change a lot. Okay. So they created app container, but we don't need it anymore because we use Hilt. So in MarsPhotos application class, we need to make it Hilt app class, right? And get rid of this stuff inside. Because by default it's empty unless we really need to content. If we use work manager, we will have to add content. So it's not always empty. So I delete the stuff and I add Hilt Android app on top. This class is already inside of manifest because we define it app class themselves, and if we defined app class, application class, we have to include it inside of manifest. So it's already here, we don't need to edit. Also, permissions for internet is also here, because they have it, obviously. Going back, application class exists. Next, since we use Hilt, we need to add on top of activity Android entry point. Because we use view model associated with activity, and we will use injection into view model. Here it is. Next, inside of view model, factory is gone because we deleted container inside of application. And we will need to delete this piece because factory will be generated by Hilt. So I just deleted inside of view model the code for the factory. So we need to take care of dependency injection now. So inside of data, we may create module for injection building, essentially building API, right? Web API. So I need something like this inside of data. Inside of my remote data, I have retrofit module that is creating a retrofit object and data-based and implementation of the API using retrofit. So I need to create something like this. Retrofit module, right? In order to do it. So let's do that. New object, new Kotlin class file object, retrofit module. Add. On top of the object, I need this. Okay. To make it usable for Hilt, inside of it, I'm creating a retrofit piece, but with different, obviously different address, right? Copy. So this will be providing a retrofit object, right? Provide retrofit object. We need base URI. They define base URI inside of app container. See, base URI. So I will pick it from here. Copy. And it goes into my retrofit module. Paste. All right. Now, I use it Moshi library, but they use different libraries, so I need to look up how they do it. Okay? So this needs to be replaced by their code. So for this reason, I'm looking for their code in app container. See what they use? Add converter live factory, this piece, right? So I copy this stuff, and it goes inside of retrofit module instead of Moshi library. Okay. Paste. This part is done, but I'm still missing implementation, right? So I need something like this. But it's not pet data, it is their API, whatever they call it. Right? All right, so I will copy paste this part, but I will replace this pet data API with their code. Okay? Copy and paste it here. Obviously, this is wrong name. in EPP, where's there? It's called, no, MarsPhotos API service. This is how they call this interface. So I need this name. MarsPhotos API service. In my case, it is Pet Data API, so it's different name. So I do copy the name, just name, and I'm going to the module, and this is their name. Paste. Paste. Okay. So I'm done with retrofit module. Okay. So this part is creating retrofit. This is creating. This has to be renamed, right? Name is not important at all. It will work even if I keep Pet Data API. What is important is code and return type. So even if I keep Pet Data API, it will be fine, but I want to change it to Mars Data API. Otherwise, Pet has nothing to do with it, right? Mars Data API. So I'm done with the retrofit module. The next step is to, by the way, why it doesn't compile? Let's click on red. Red means something is wrong. Oh, okay. Quotation mark is missing, probably. I didn't copy the entire piece. So I missed entire line, something in this line. I didn't copy till the end, so Command C. I need to fix this part. Command V. Now it's happy. All right. Next, I need to link a repository to implementation. Or they don't have MarsPhotos repository. They have interface and they have implementation. Since I will use dependency injection, with Hilt I need to link them together. That in order to create MarsPhotos repository, use this implementation. This instruction comes in repository module. Unfortunately, it cannot be done within the same module because one is object, the other one is abstract class. It's different things. So I also need to have a repository module. So new Kotlin class file, and in this case it is class repository module. Repository module. Enter. Okay. And I need stuff on the top of it, and this is abstract class. Abstract class. So what is inside of my repository module? I need this on top, and I need binds that links repository implementation and interface. So we'll need binds, okay? So first I will copy paste this part on top. All right. And I need binds. Copy. That will link repository implementation and name of the interface. First, let's look up the interface. Where do they declare interface? In repository. Okay, here it is. It's called MarsPhotos repository. Since this part of the file, and I'm going to delete this file, maybe. So let's move it out of the file, okay? So how to do it? Or just keep it. Doesn't matter. Let's keep it. Let's keep changes to minimum, unless we really need to change. So going to repository module, this is interface. Because if we start to change, make unnecessary changes, it will be forever. Paste. Now we need to replace this, implementation. And this is implementation name. Copy. This is implementation name. Paste. Now it's happier. So I created repository module that binds repository to implementation. Name is not important, but I will rename it to Mars because pet has nothing to do with it. Okay. Next. So repository is done, modules are done. Container doesn't contain anything else which is important. So at this level, we can delete it. But let's keep it for now. But it is probably time to delete it. Retrofit module. Already I copied everything. Let's fix Mars view model, because now I'm using Hilt dependency injection instead of manual dependency injection, right? So for this reason, in Mars view model, I need to tell that it is Hilt view model. Hilt view model. And this is injected by Hilt now. So I'm converting this to code for Hilt dependency injection. In inject constructor this. Okay, so I'm just going to extra line to make it clear. Let's see if it understood it. This is coming from, injected from this. Right? So it is understanding so far. And it doesn't understand where this is coming from. You see, there is no link where. It means I need to edit this code, right? So let's open that. And what should I do? I need to add dependency injection to it, right? So how to do it? Inject constructor. Here it is. So going back to my view model and see if it's understandable right now. Okay, this is coming from here, and now we have a link where to here, right? And this is coming from here, right? And this is coming from here. So all links are created for dependency injection, hopefully. Okay. So now let's try to delete app container. And we have one more step which is missing. I delete app container now. Delete. It's gone. I selected save delete. It means it couldn't find references. So it's no longer used. Now in my home screen, I do have arrow. No, it's not in home screen. Okay, it is in Mars app arrow. See? Because factory doesn't exist anymore. But who cares? Because factory is provided by Hilt now. So I deleted factory. And here it is. So let's stop it from running. For safety, let's go to build clean project, because now it will I will try to delete previously generated code by the system. And now, oops, I go to rebuild project to make sure that everything is rebuilt, because I did major changes. It has unresolved reference to app container. Let's find it and delete it. Here it is, see? Delete it from import. Let's rebuild again. So it was referring to import that I deleted files. Build, rebuild project. Build successful. Run. Ta-da! So this is, hopefully it's useful. Okay, so I showed how to replace manual dependency injection with Hilt dependency injection with minimal changes of the code, only necessary changes of the code. Obviously, we can reorganize it the same way as in pet data, but I don't see a point.